And finally, we are on to carbon dioxide. So let's once again count out our valence electrons. Carbon is group 4A. Oxygen is group 6A. This implies that carbon brings 4 valence electrons for each carbon. There's only one carbon in our formula. And it will bring a total of 4 valence electrons. Oxygen, being group 6A, implies that it's going to bring 6 valence electrons. There's 2 of them in our chemical equation. And so it'll bring a total of 12 valence electrons from the oxygens for a total of 16 valence electrons. Now we need to determine the central atom. Again, we use the rule of thumb that the least electronegative atom is the central atom. So carbon, because it's the least electronegative. All right, so with this in mind, let's draw this out. So carbon is the central atom, and we have 2 oxygens. We'll just draw one bond between both of those. And let's count up how many electrons we've used. It's going to be 4 valence electrons used. And so we have 12 valence electrons left. We can check on our octet rule here. This oxygen only has 2, so its octet rule isn't fulfilled. This oxygen only has 2 valence electrons, its octet rule isn't fulfilled. Carbon has 4 valence electrons, so its octet rule is not fulfilled. We're going to assign the rest of these 12 valence electrons to try to fix this. So that means we have our central atom, carbon, surrounded by oxygens, and we're going to evenly distribute these 12 electrons to each of these oxygens. We're going to do it in pairs. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now we've got all 16, so 2, 4, 6, 8, 10, 12, 14, 16 valence electrons used. We have no valence electrons remaining. And we can check if our octet rule has been fulfilled. Carbon has 4 valence electrons, so its octet rule has not been fulfilled. And this oxygen has 2, 4, 6, 8, so it's been fulfilled. And this one has 2, 4, 6, 8, so it has its octet rule fulfilled as well. We just need to fulfill the octet rule of this carbon by giving it 4 more valence electrons. The way we will do that is each of these carbons will form another bond. Each one of these oxygens, rather, will form a double bond with the carbon. So that will be carbon, oxygen, oxygen. Each of these has a double bond, and we can draw in our remaining valence electrons. 1, 2, 3, 4, 1, 2, 3, 4. And that's so 2, 4, 6, 8, 2, 4, 6, 8, that's 16 valence electrons used, 0 valence electron remain. Carbon has 2, 4, 6, 8, so its octet rule is now fulfilled. This oxygen here has 2, 4, 6, 8, so its octet is fulfilled, and the same with the other oxygen. And so we are ready to build the model. Okay, here's our Lewis diagram for carbon dioxide. We're going to build a ball and stick model for this. So here's our carbon, here's our oxygens, and we need a total of 4 bendy sticks to do this. So I'm just going to build it from left to right. Okay, so there's the first oxygen. And here is the second oxygen. So this is the bond angles between the carbon and the oxygens are all at 180 degrees, and that makes this a linear molecule. So we can prove this also by looking at the bonding domains around the carbon, the central carbon atom. So let's take a look at those electron domains around this central carbon atom. We have 1 electron domain in this double bond and 2 electrodomains when we count this other double bond. That's a total of 2 domains. Both of them are bonding domains. There are no lone pairs. When you look up on your table, you're going to find that that is a configuration for a linear geometry.